The Net Zero Energy Ready Challenge is a Clean BC incentive program and juried competition for large buildings launched in 2018. It provides financial support for developments targeting net zero energy ready levels of performance and aims to celebrate, promote, and learn from BC's most innovative and energy efficient projects. Integral Group and Vancouver's Zero Emissions Building Exchange have commissioned a series of 6 technical playbooks and accompanying videos to help our development, design, and construction communities make net zero energy ready buildings a reality before they are required throughout the province in 2032.
Hi, my name is Monty Paulson. I lead the Passive House team at RDH Building Science, where we plan passive house buildings and other high-performance buildings every day. I'm here to talk about how to plan high-performance buildings and specifically how to develop milestones that will meet the metric you're trying to build to and the budget you're trying to build to. The first question I get asked more often than anything else is, how much does it cost to build a passive house multi-unit building or a step 4 multi-unit building? And the answer is, in our projects, we're seeing construction cost increases between 0 and 9%. Now keep in mind that's just construction cost. A 9% construction cost increase, when added with other development costs, might be a 2 or 3% increase to the overall cost of the project. But the question I hope you put in your minds is not what is the average cost. The question I'd like you to focus on is, how do I reduce the construction cost premium of my project closer to 0 and not as close as 9%? Because this is what the teams that do it over and over are doing. They are achieving high performance buildings at par with code minimum buildings. And the best way to think of it is to make sure you don't essentially retrofit your old design into a passive house or step 4 building. So think about the last multi-unit building you did. It probably had features. Many architecture firms specialize in multi-unit and have a real sense of how to design these things in an elegant way. If you take the last building you developed and think of that as your baseline, the worst building you can legally build cost 100%, and you were to add to the last building, the last plans that you developed, 6 inches of extra insulation, triple pane windows, high performance heat recovery ventilation, of course it's going to cost 10% more. How could it be otherwise? You take the same thing, you add some extra stuff, it costs 10% more. That's how projects get to the high end. If you want to get to the low end, if you want to get closer, you need to think differently about the building from the very beginning of the design process, from even before the design process. You need to think about a building that's a little simpler and a little more tuned to its high performance pieces. You need to put this in the owner project requirements. So if you can get the cost of a streamlined code minimum building down to something like 90%, through this simplification, things like limiting the window ratio, reducing surface area, compact mechanical cores, and other features that are discussed in this presentation and some of the other ZEBx presentations in high performance, and you articulate these well in the owner's project requirements, then when you add that extra insulation, then when you control for windows and other things, you're up to like 95% of cost. And then you could add back features you really love. Maybe you really want brick cladding, or you really want more space for a big atrium at the entry or something like that. That's how you get a building closer to par. You start by making the really hard decisions at the beginning of the design process, not by doing everything you did before and adding extra stuff. In other words, you're not retrofitting your last design to be a high performance building, but you're rethinking the nature of the process from the very beginning. There are some great case studies. This one's published by ZEBx about a project named Orion in Pemberton. This is a step 4 building that was built for below cost of conventional buildings at the time. It's an elegant multi-family commercial project. It's worth looking at this case study, and there's quite a few more projects here in BC that are being completed in 22 that we believe will also be hitting very close cost parity with conventional construction and achieving passive house or step 4 levels of performance. So, let's say you've decided, I want to try that. I want to design my building differently, and I want to track a way to have a much more affordable, high performance building. How would you do that? Well, most architectural practices develop milestones and Gantt charts. Most developers manage to milestones around funding requirements. Teams manage to milestones put forth by municipalities, where by a certain date you have to submit for rezoning or a certain date for design development. What we're suggesting is that you add milestones geared to high performance and overlay them with your financial and development timeline milestones so that you understand what you need to do by a certain date and you can review your process as you go forward. Most of this presentation is going to be an overview of those milestones, and we'll go through them all at the beginning and then we'll come back and cover some of them in a little more detail on a second pass. So, typical project milestones for high performance projects include a strong owner's project requirements during pre-design. It's very important that the owner know what they want to build, they know what target they want to build to, and they have some sense of the key strategies they're going to use to get there. Simply saying, hey, it's going to be a passive house or it's going to be step 4, you figure it out, is not enough. The owner needs to speak up for strategies that work for them. What's your window to wall ratio? What's your surface factor? How are you dealing with mechanical? How are you planning ventilation? How are you structuring the consultant team? Once the owner is clear about the standard they want to meet and how they want to meet it, they're in a far better position to interview and hire consultants to help them get there. For example, if the owner knows they want to build a passive house multi-unit building, you're going to look for an architect that has done a multi-unit passive house. You're going to look for a mechanical engineer who's done a multi-unit passive house, and you're certainly going to look for a passive house consultant who's done a multi-unit passive house. Your goal as the owner is to be the only person at the table who has not done this type of project before, or as close as you can realistically come to that. And as soon as you have that team in place, you then work with them to develop a custom set of milestones like those we're talking about. At the beginning of schematic design, you want to do an integrated design workshop where essentially you make a quick dry run of the entire building. In one day, you want to look at the performance targets you're going to need to hit for everything from the overall wall value to the ventilation rate to what kind of dryers and refrigerators you're going to put that building. And so it's a bit of a blitz through everything, and it starts with an energy model prepared prior to the design charrette, where they're taking simply the available box. We don't have an interior layout, it's an approximate number of units, and they've made guesses of, based on this amount of occupancy, based on this amount of ventilation, here's what our wall factors have to be, here's what our window factors have to be. And the energy model inputs drive the day's agenda, saying, great, our walls are about R35, how are we going to build those? The contractor says, well, we really like this assembly or we really like that assembly, and so you make an initial decision. And you go all the way through the list that way. And the goal is by the end of the day to have covered all of the most important functions of the design as placeholders, as basis of design decisions that will be further reviewed through SD and DD. Getting there by the end of the day then allows someone to cost many of those pieces. And it's important through this whole process that the person running the budget and the person running the energy model are using the same sorts of inputs. This first energy model, again, it's setting targets. It's not based on specific, it's based on guesses, and should have a big buffer because it's based on guesses. Just like your initial budget has a buffer to some degree, you want your initial energy model to have like a 20% buffer at this point, because we know things are going to get a little tougher as we get into more specific pieces. And at the schematic design workshop, we should be looking at mechanical, not only form, not only what we need to present to the city for rezoning, but we should be looking at, are we looking at a local ventilation strategy or a central ventilation strategy? What sort of windows are we looking at? These key components should be discussed early, and you might want to refer to the ZEBx playbook and presentation about ventilation for a little more discussion on that. During design development, we're moving to look to set the specifics for those targets we set in SD. So we said it's an R35 wall. Exactly what R35 wall is it? What's the makeup? What makes a lot of sense? Does it have a degree of prefabrication? Is it all built on site? What are our install details for window? What are install details for door? How do we make that critical junction typically between a wood frame mid-rise building and the concrete parkade on which it sets, which can often be a source of moisture and energy leakage? These kind of details are often new for an architectural team that has not previously done a high performance building, and they can't be delayed till construction documents because you need to prepare accurate assessments of them for the energy model and also be tracking what they imply for the budget for the building. So it's important to front load details. Now, an architectural team that has done a passive house previously or a low energy building previously has a huge leg up because they already have sample details like this. So using teams that have developed these details previously give you a big leg up. We're also going to identify key components. What are the window systems? What are the ventilation systems? And we actually might do some pre-tender at this point to make sure, okay, these are the 2 or 3 units we can get to bid on this, and create a sort of controlled pre-tender so that we're not revisiting these questions in value engineering, and we understand the performance of critical components in these high-performance buildings. And then we'll typically conclude design development with a second energy model that is very different from the first. The first energy model was all guesstimates and was about setting targets. The second energy model is starting to put in specifics. And so we have specific wall systems, we have specific window installs, we have specific curb details, we have a specific basis of design ventilation system and other pieces. And we're saying, yes, if all of these specifics come together, we can still hit our code or standard set targets. And we probably have a little less buffer at this point, more like a 10% buffer as we continue into construction documents. When we get into construction documents, on high performance projects are often introducing new details and concepts, and it's not uncommon for us to discover that the structural engineer and the mechanical engineer and the enclosure engineer have slightly different interpretations and that their details don't all match. And so working out those inconsistencies between the architectural set and other sets is tremendously important, and making sure the specification is exceedingly clear and very focused so that the tender can be accurate and there is not wiggle room that leads to communication failures and possibly the wrong thing being bid. It's also time for construction documents to start training the site team to make sure that the people who are going to build this project understand the plans, understand what's new, and that they are trained in some of the new installation details. And during construction documents, we develop what we call the verification plan. Some people call it a quality assurance or quality control plans. Whatever you call it, it's a careful roadmap of who is going to check what during construction, who goes to who to answer a question, and where we come up with those answers when we need to. As we get into construction, we have a pre-construction meeting or a construction kickoff. This is a tremendously important meeting of equal importance as the integrated design meeting that kicked off our design phase, where we need all of the construction managers and key vendors in a room at one time or in the trailer to go through key details, to talk about what makes this building unique, to get their input on some of the assemblies and materials and membranes and supplies, and to make sure they understand what is critical to achieving the standard. And typically the pre-construction meeting will include or lead up to some mock-up training where we go through the specific details on site. Now again, if you've hired a contractor who has done these high-performance details, who has built a similar building previously, you can lighten up on the mock-ups a bit. But if this is the first project of that window type, of that window install, or of that insulation type, it's very important to do mock-ups. And if you're achieving a third-party standard, like a certification from Passive House Institute, which can be required by the City of Vancouver or other jurisdictions, you'll want to receive your approval letter from your Passive House certifier during pre-construction, because it is required to have that letter before the jurisdiction will give you a construction permit. So it's critical as a milestone to understand, well, if I need final approval from my certifier at the end of pre-construction, when did I need to get documents to my certifier? Probably early in construction documents. So during construction, we do regular enclosure mechanical reviews, no different from any other project, but we make sure they're tracked to the verification plan, and that if anything goes awry, we sort of stop quickly and huddle and figure out how to get on it. We can't allow slow reports from site visits to cause weeks to go by before we get back to something that might be an air barrier failure later. And of course, we're doing ventilation commissioning during this phase, a tremendously important piece, and air tightness testing. And again, note that there's a ZEBx presentation like this on ventilation and one on air tightness that can deal with those in more detail. Finally, at occupancy, we're going to issue an occupancy handbook or a video or some sort of training so the residents understand the building they're living in and understand how to operate it. We'll do some post-occupancy monitoring so that we can all see how the building's performed over time. And we really encourage teams to do a debrief and prepare some sort of case study so we can share some of these lessons as we all move to this being the standard by about 2032 in British Columbia. Okay. So, developing the owner's project's requirements. This is a tremendously important step that sometimes is glossed over when we've done projects repeatedly with the same standards for the same types of owners. It's really important that the owner know what code or standard they're going to, and not only say in the OPR, we want to be a certified passive house, but say we want to be an affordable certified passive house with these specific targets that we're going to look to increase affordability through a modest window-to-wall ratio, through careful form factors, through balancing our ventilation rates very carefully, or other strategies. It may require the owner and/or the architect and our key consultants to meet even before schematic design and have discussions with people who are experienced in achieving step 4 passive house buildings and debate a bit. What target should we go to? What should our strategies be? That is a smart investment for the owner to make, to have those meetings before you have a whole table full of consultants. So you can focus on the target that makes sense and have clear instructions to the consultant team as soon as schematic design starts. It's also important at this phase to specify not only a budget, but what the budget process and budget milestones are going to be, and make sure the budget milestones seem to sync with what will wind up being slightly accelerated planning milestones, and make sure that we don't end up with all of the budget review happening at a value engineering phase. It needs to come regularly. One architect I work with says, make the hard decisions first, right at the beginning, and it makes it much easier later on. We need to have measurement and verification ambitions, targets in place in the OPR. You don't need the complete plan, but a statement of what we're going to measure, how we're going to verify it, and what third-party contract that might represent. And if there are other specific sustainability requirements, that they be named. It's not helpful for owners' project requirements to have a sort of list it all. We're going to be green and no embodied carbon and green roofs and passive house and living building challenge. Big laundry lists aren't helpful. Hard decisions are. We want this kind of green surfacing. We want to track embodied carbon to this metric. We want to achieve the international standard to this way. The more specific the sustainability requirements are in the OPR, the more cost effective the team can design to them. If you put really broad objectives, the team will often come up with broad ways to achieve them, which will cost more money. Okay, so what are our milestones during schematic design? That integrated design meeting is everything. A real charrette. It needs to have the architect, the mechanical engineers, possibly structural unless it's tremendously simple. Certainly the passive house or energy consultants are engaged. Probably enclosure consultants are engaged. And you're going through, in a quick rough draft, a basis of design decision for everything in a high performance building. The purpose of this is twofold. One, you set targets so then you can move into design and start designing actual assemblies to those targets. The second is that as you go through this list, there might be something that some team members weren't expecting. They didn't understand how ventilation was going to influence the hallway and the corridor pressurization. Or maybe they didn't understand that, conventional dryers can be difficult to put in high performance buildings. Identifying these misunderstandings at the very first meeting gives your project time to say, great, we need to go have a conversation with the operators and passive house consultant about dryers. Let's have that after this meeting so the decision can be made within the next few weeks, where we don't discover those conflicts or misunderstandings until the end of design development. It becomes very expensive to address them. Some of the high performance strategies we typically cover, among many others, in that early charrette are: where's the mechanical going? Making space for the mechanical early in the process. How are we designing for overheating and make sure we retain summer comfort, not only now, but over the next 50 years when the outside temperature is warming, particularly summer nights are warming? How do we optimize the form factor and make sure this building can be as affordable to build and lose as little heat as possible? How do we optimize ventilation? Sometimes there are minor conflicts between the objectives of, say, the passive house or step 4 requirements and conventional practice. And what assembly makes the most sense for this building and this contractor? How do they want to build an R35 wall? And what they identify as the challenges should drive the design more than any theoretically perfect R35 or whatever your target is wall. It's tremendously important to identify if you're going for a centralized ventilation strategy, or have a big machine and lots of local units, or a localized ventilation strategy, or some hybrid. I'd love to talk about this at greater length, but there's another ZEBx video about this, so I urge you to listen to Patrick go through these options. The point I want to make is you need to make this decision on general approach at the beginning of schematic design, and the owner or operator needs to be deeply involved because there are implications for how the building's operated in this decision. And there are spatial implications in this decision. And so you want to have your ventilation strategy in place before you start laying out the unit layouts, or else you're going to be painting yourself into a corner and having to readdress your unit layouts consistently in order to squeeze in the ventilation you choose. So what are our milestones during design development? We come out of schematic design with some good targets and some big picture strategies and a clear sense of the work we need to do for teams to discover new potential issues with the high performance target. As we get into design development, it's tremendously important to draw those details first. Most architectural practices have big libraries of details they developed over many, many years that they use on multiple buildings. The challenge to an architectural practice is that the high performance building involves all new details, and so that library is suddenly no longer as useful. And the challenge for the building specifically is that we don't need those details at the end of construction drawings. We need them at the beginning of design development so we can get thermal models of them and understand what implications they have for the energy model, not to mention the budget. And so it's tough on architects to do their first high performance project, their first passive house multi-unit, their first step 4. But the good news is the second one's much easier because you've already drawn those details. So if you can bring on a team that's done it before, you're over the hurdle. If it's a first project for an architectural practice, there simply needs to be clarity that they are going to need to front load a lot of that drawing in the process because it needs to be reviewed. It's an iterative process. They'll draw a detail, the enclosure consultant may have some feedback, the passive house or energy consultant may have some feedback, and they simply need to get on that at the beginning of design development, and so there needs to be some milestones in place about when the detailing is going to be done. The other piece that's so important to achieving summer comfort is understanding the role of shading in these buildings. Conventionally, we think of shading something like this, as a light shelf above the window, and that certainly has been what it's been. But as we look at managing heat gains in a changing climate, we need to get much more aggressive about shading. And we need to think about multiple light shelves. We need to think about adjustable exterior shades that prevent heating from hitting the windows. And of course, it's much more efficient if the shading's outside the window than inside the window. And there's lots of ways adjustable shading. It can look like French doors. It can be sliding panels, such as this building in Seattle. We don't have the space here to go through all the shading options, but it's very important that there be a milestone around looking at shading and summer comfort and cooling options. You may need to meet a specific target in the City of Vancouver or to BC Housing to prove that you can maintain summer comfort in the future. And so it should be a milestone around addressing that issue. The second energy model is very different than the first energy model. Where the first energy model was setting targets based on guesses, the second energy model is about plugging actual values in for each of those guesses. So first you have to have the drawing and the decision about lots of those pieces, and then somewhere halfway through to the end of DD, you can start inserting those actual numbers and you see if the building is really on track to achieve its code or standard. You would anticipate a smaller buffer at the end of this model, but you have more confidence that your numbers are correct. So what milestones do you have during construction documents? The planning process starts to resemble conventional planning process at this point, with the exception that you probably have new details that have to be more carefully reviewed for conflicts, that you may have slightly different details from structural, from architectural, from mechanical, and it's really important to make sure that the planning set comes out consistent so you discover these potential disagreements in CD rather than in the construction trailer. Also during this time, we start training the site team. This can be informal if it's a small project and you have great consultants who can lead them. It could be a formal training, such as having numerous people on your site team go through the training at BCIT or from Passive House Canada or other sources. If you have a construction company that has built high-performance buildings of this type previously, you may be able to skip some of the site training because you may have people already trained. It doesn't matter how you get there. What's important is that you have a milestone that you assess. Who are the site leaders? What background do they have? Are they appropriately prepared for this project? And we're preparing the verification plan or the quality control plan. Who's checking what? Who are they reporting to? We typically prepare elaborate spreadsheets and forms to make sure that everybody knows what's happening. In addition to the paperwork, it's just very, very important that anybody on site who finds a detail that doesn't make sense to them can take a photo of it and send it to a site supervisor or an air barrier or somebody in the construction team and say, does this look right? And if the construction leader doesn't understand, they can quickly forward it on to the enclosure consultant or the mechanical engineer and say, does this look right? And everybody knows who to go to get a quick check. What we want to avoid is questions that remain unanswered in the field for weeks on end because you waited for somebody to come to a site visit, they took a picture, they had a concern, it took them 2 weeks to put out the site visit report. Quick feedback is tremendously important to keeping new typologies of high performance buildings on budget. All right, milestones during pre-construction or tender are really a continuation of what we were just talking about. We need to do that on-site training with mock-ups with everyone now. In our previous phase, we trained the leaders, and now we're bringing all the construction people together to sort of learn how to put in a window, to learn how to put in a door, to learn how to insulate pipes, and to understand the mistakes that they might come across. This is typically just a day, but tremendously valuable, first in that everybody gets some hands-on training in that particular assembly technique, and second, that this stays on site, and so as new employees come along and they're trying to figure out how to do something, they can go back to the mock-up and take a look at it. It's not uncommon for Passive House multifamily projects to have 2 or 3 mock-ups kicking around in the parkade or in some tents near the construction shed. Milestones during construction, again, are fairly typical. We'll have enclosure reviews with more checklists to make sure we're achieving Passive House standards and thermal bridge standards that have been set. We'll typically have quite a few more mechanical reviews. We need to make sure that the entire hot water system is insulated to a high degree. We need to make sure that the ventilation system is commissioned, that the ductwork itself has been tested, and that the final heating and cooling system is tested and commissioned carefully as it goes in. And of course, ventilation commissioning is a new component that often needs to be thought about. Again, planned early, tendered early, some third party that's going to make sure that every duct and register flows at exactly the rate it's supposed to flow. And part of this commissioning needs to be done during construction so that you don't cover it all up with drywall and then have to rip out the drywall to go back and fix something. And then finally, air tightness testing, tremendously important, typically a mid-construction blower door test as soon as some portion of the building can be sealed off, and a final blower door test. It's worth noting that an investment in good air tightness detailing doesn't cost any more materials. It's the same cost as bad air tightness detailing, and so a little bit of extra labor and focus through this process can make a big difference on an energy model, and it's often how buildings that are struggling to meet their code or standard can make up the difference at the end, is with a air tightness performance that beats the estimated metric early in. So investing in this is one of the most affordable ways to improve the performance of the building and achieve standard. And finally, at occupancy, it's really important that the people who are going to live in the building or use the building as an office understand what it is and how to operate it. It's worth thinking of maybe 3 tiers of occupancy handbook. At a minimum, a short written document, 5-10 pages, explaining how the buildings work. How do you open the window? What if you do when you're too hot? What if you do if you're too cold? How do you adjust the ventilation? What are the purposes of some of these controls? A step up from that is a short video that as additional residents move in, they can watch the video and learn how to operate in the units. And the gold standard for occupancy training is to actually have someone on site who is kind of the coach for new occupants. And when someone moves into the building, that person welcomes them and just takes a few minutes to show them how to operate their unit, and is available as they have some additional questions a week later. It's important that every manager consider the appropriate level of occupancy training for their project, and that discussion happen fairly early in the planning process, so this can be prepared during construction. And finally, we strongly encourage post-occupancy monitoring. BC Housing and City of Vancouver are also encouraging this as a way to get benchmarks on these buildings and see if they're actually achieving the performance standards that we're spending all this work and effort to make sure we achieve. So that's our overview of how to plan a high-performance building. Your project will be different. What's important is that you set a clear OPR and good milestones for your project that meet your expectations. For more information about planning high-performance buildings, please see the full playbook on the ZEBx website. This presentation is part of the ZEBx Net Zero Energy Ready Playbook series, and look at those other videos too. My name is Monty Paulson. I'm the Passive House Specialist at RDH Building Science, and it's been a pleasure to be with you.